There's a small circuit board roughly the size of a deck of playing cards that you can order online or pick up from an electronics supplier for $12. You connect it to any 12-volt battery, the same battery sitting under the hood of your car right now, and it becomes a precision induction heater capable of removing seized bolts, frozen brake caliper pins, rusted exhaust studs, corroded plumbing fittings, and stuck suspension components in 10 to 30 seconds without producing a single open flame. Not a propane torch that costs $40 in fuel every season, scorches surrounding metal, melts nearby wiring harnesses, ignites undercoating, and sends you to the emergency room when it lights the penetrating oil you just sprayed across the entire work area. Not a $500 mini ductor or bolt buster sold by professional tool companies through exclusive dealer networks at markups that would embarrass a luxury watch brand. Not a 3-day penetrating oil soak that still leaves you rounding off bolt heads with a breaker bar while your knuckles bleed against a rust-locked exhaust manifold at 10 p.m. in your garage. Not a $180 per hour mobile mechanic who charges you 2 full hours of labor to remove a single seized caliper bracket bolt using the exact same induction technology I'm about to hand you for the price of a sandwich. This device heats only the metal you target. It does not heat the bolt itself. It heats the surrounding metal, expanding it microscopically, breaking the corrosion bond that welded the two surfaces together over years of road salt and moisture exposure, and allowing the fastener to turn freely by hand in most cases. No fire, no smoke, no burned rubber bushings or melted plastic connectors, no scorched paint, no risk of igniting fuel vapors in an enclosed engine bay where a single spark from a torch tip could put you in a burn unit. A caliper bracket bolt that has not moved in 9 years of road salt and brake dust exposure, freed in 15 seconds while you hold a device that weighs less than a pound. An exhaust manifold stud that snapped the last time someone tried to force it with an impact gun, now heated evenly and extracted with a standard stud remover in under a minute. A suspension bolt frozen into an aluminum steering knuckle on a vehicle where using a torch would destroy a $340 wheel bearing, pressed in 2 inches away, removed safely and surgically without transferring meaningful heat to any surrounding component. The professional tool industry knows this device exists. They have known since 2008 when Chinese electronics manufacturers began producing the ZVS driver module for industrial applications, and the open source engineering community realized what that same circuit could do inside a home garage. The tool industry's response has been exactly what you would expect from companies selling $500 versions of a $12 component. They never mentioned it. Not once. Not in a single product catalog, a single trade show demonstration, a single sponsored tool review, or a single weekly sales pitch delivered off the back of a tool truck inside an automotive repair shop anywhere in North America. The physics behind this device are 193 years old. In 1831, Michael Faraday demonstrated electromagnetic induction at the Royal Institution in London. He proved that a changing magnetic field could induce an electric current in a nearby conductor, and that the reverse was equally true. An alternating electric current passing through a coil of wire generates a rapidly oscillating magnetic field around that coil. When a conductive metal object is placed inside that field, the oscillating energy induces tiny circular electrical currents within the metal itself. These are called eddy currents. Eddy currents encounter electrical resistance as they flow through the metal, and that resistance converts the electrical energy into thermal energy. The metal heats from the inside out uniformly and rapidly, without any external flame, without any physical contact, and without heating anything that is not directly inside the magnetic field. By the 1920s, industrial manufacturers were using induction heating to harden steel, melt metals for precision casting, and heat treat engine components on factory production lines. The technology was faster, more precise, and dramatically safer than open flame heating, but it stayed locked inside factories for decades because the power electronics required to generate high-frequency alternating current were expensive, physically large, and demanded specialized engineering knowledge to build and maintain. That barrier collapsed in the early 2000s. A circuit design called the Zero Voltage Switching Driver, originally developed for high-efficiency power conversion in telecommunications infrastructure, was adapted by electrical engineers who recognized that the same topology could drive an induction heating coil at the exact frequencies needed to heat ferrous metals using nothing more than a standard 12-volt DC power source. The circuit is almost absurdly simple. 2 MOSFET transistors, 2 capacitors, a hand-wound copper coil, and a handful of supporting components. The entire assembly fits on a board smaller than a credit card. When Chinese manufacturers began mass-producing these driver boards for industrial heating applications, the retail price dropped to between $8 and $20 depending on the power rating. The moment these boards became commercially available, every branded induction heating tool sold through professional distribution channels became functionally obsolete. Not slightly inferior, obsolete. The $12 board and the $500 branded tool operate on the same physical principle. They generate the same type of alternating magnetic field. They induce identical eddy currents in identical metals. They produce the same thermal result at the same target location. The only differences between the two are a plastic housing, a recognizable logo, a warranty card, and a 4,000% markup that pays for the tool truck lease, the sales commission, and the financing plan that keeps a $28 per hour technician paying $20 per week for 6 months for a device he could have built during a lunch break. But this is not just a story about tool markups. The economic structure surrounding seized fasteners extends far beyond the price of the device used to free them. Let me show you how much money depends on your bolts staying stuck. The professional automotive tool market in the United States generated $8.4 billion in revenue in 2023. Mobile tool distributors operating those familiar trucks that visit repair shops every week selling wrenches, sockets, diagnostics, and specialty equipment work on average product markups between 300 and 700%. The induction heater category alone represents a growing segment as manufacturers market these tools as essential equipment for any shop working on vehicles in Rust Belt states. A branded induction heater retails through these channels for $489 to $649, offered on weekly payment plans designed to make the price feel small while the total cost remains enormous. The larger revenue impact sits inside the labor economy that seized fasteners create. The published flat rate labor time for replacing a rear brake caliper bracket on a common domestic pickup truck, a job that involves removing 2 slide pin bolts that are seized with corrosion in virtually every example over 5 years old in northern climates, is 1.2 hours. At a standard shop labor rate of $150 per hour, that produces a $180 labor charge for a repair whose primary difficulty is not the brake work itself, but the extraction of 2 corroded bolts. If those 2 bolts were freed in 15 seconds each by an induction heater, the actual hands-on labor time for the entire brake service drops to roughly 25 minutes. But the shop still bills 1.2 hours, because the flat rate book assumes the fasteners will fight. The difficulty of seized hardware is not an inconvenience that the repair industry tolerates. It is a profit center the repair industry depends on. Across the full automotive service sector, conservative estimates indicate that seized and corroded fasteners add between $2.8 billion and $4.1 billion in annual labor charges to customer repair bills in the United States alone. That figure accounts for inflated labor times on brake work, exhaust system repairs, suspension component replacement, and engine accessory services where rust and corrosion transform 30-minute procedures into 3-hour struggles billed at premium hourly rates. A $12 device that eliminates seized fastener difficulty does not reduce these costs by a manageable percentage. It collapses the entire labor premium built on top of corrosion. That is why no major automotive media outlet that accepts tool company advertising has ever published a review of a ZVS induction module. That is why no tool truck distributor stocks $12 boards alongside their $500 branded units. That is why the branded version exists at all, not because it performs differently, but because the industry understood that if the $12 version reached every driveway and home garage in the country, the labor model and the tool financing model built on top of stuck bolts would lose billions in combined annual revenue. This is the exact pattern we track at Forbidden Arena. Practical solutions engineered into obscurity because they threatened revenue models that depend on your lack of access to information. We have assembled complete downloadable guides on emergency power generation, water purification, food preservation, and mechanical repair techniques that were systematically stripped from publicly available manuals after the industries they disrupted made them commercially inconvenient. No subscriptions, no recurring charges, no padded content designed to justify a monthly fee, straight information directly delivered. The link is in the description below this video. But stay right here because I am about to walk you through the exact components, the exact assembly, and the exact operating technique that will make every seized bolt you encounter for the rest of your life a 15-second inconvenience instead of a 2-hour ordeal or a 4-figure repair bill. Here's what you need. First, a ZVS induction heating driver module, available from any major online electronics retailer. Search for ZVS induction heater driver board. The price ranges from $10 to 8 Ts. Ensure the listing specifies MOSFET transistors rated for at least 20 amps continuous current. Most modules sold for heating applications already meet this specification. Second, a work coil made from 3 16-inch outer diameter soft copper refrigeration tubing, available at any hardware store for approximately $8 per 5-foot length. You will bend this tubing into a coil of 4 to 6 turns with an internal diameter of approximately 1 inch, large enough to slip over a standard hex bolt head or surround a protruding stud. The coil does not need to be perfect. Rough hand bending is entirely sufficient. Third, a 12-volt power source capable of delivering at least 20 amps. Your vehicle battery exceeds this requirement by a wide margin. Fourth, a set of battery cables or heavy gauge wire leads with alligator clips or ring terminals for connecting the module to your power source. Available at any auto parts store for under $10. Total cost for every component, $28 to $40 depending on supplier. Every part is reusable indefinitely. There are no consumables, no gas canisters to refill, no filters to replace, no proprietary cartridges designed to create recurring revenue for the manufacturer. Assembly takes under 15 minutes and requires no soldering, no programming, and no electrical engineering knowledge. Connect the two ends of your copper work coil to the output terminals on the ZVS board. These terminals are clearly labeled on every commercially produced module. Connect your 12-volt power leads to the input terminals, positive to positive, negative to negative. Attach the power leads to your battery terminals or clamp them with alligator clips. The device is now operational. To use it, position the copper coil around the nut, bolt head, or fitting you need to free. The coil should encircle the target fastener without making physical contact. A gap of even a few millimeters between the coil and the metal surface is sufficient for full effectiveness. Activate the circuit by completing the power connection. Within 5 to 15 seconds, you will observe the target metal begin to show a faint straw-colored tint on steel surfaces, indicating it has reached approximately 400 to 500 degrees Fahrenheit. This temperature is sufficient to break oxide and corrosion bonds between the fastener and surrounding material without damaging heat-treated bolt properties, without igniting grease or rubber components, and without conducting significant heat to any component located more than 1 inch from the treatment area. Remove the coil, apply your wrench or socket, and the fastener will turn with dramatically reduced resistance. In the majority of cases, simple hand tool pressure is all that is required. No impact wrench, no cheater bar, no stripped hex corners, no snapped studs generating a repair bill 3 times the original job. For exhaust manifold studs embedded in cylinder head castings, position the coil around the base of the stud where it enters the head material. Apply heat for 15 to 20 seconds. The cast iron or aluminum of the cylinder head expands at a faster rate than the steel stud, breaking the corrosion bond from the outside inward. This is the same differential expansion principle used by every professional-grade induction heater on the market, executed here by a circuit board that costs less than a drive-through meal. Several precautions are essential. Never operate an induction heater near fuel lines, fuel tanks, fuel rail connections, or any area where fuel vapor may be present. The device produces no flame, but the heated metal surface can ignite flammable liquids or vapors on contact. Do not use the device on fasteners immediately adjacent to pressurized hydraulic lines, including brake lines containing fluid, without first relieving system pressure and placing absorbent material beneath the work area. Do not heat any single fastener continuously for more than 30 seconds. Excessive heating can alter the metallurgical properties of both the fastener and surrounding casting material. Always wear heat-resistant gloves when handling metal that has been treated. Heated fasteners and surrounding surfaces retain dangerous temperatures for 60 to 90 seconds after the coil is removed. One additional technical note worth understanding: this device heats ferrous metals, steel, cast iron, and their alloys most efficiently due to their high magnetic permeability. It heats aluminum and copper less aggressively, which in practical application is actually an advantage. When removing a steel bolt seized inside an aluminum housing, the aluminum expands away from the steel faster than the steel itself grows, creating exactly the differential movement needed to break the bond without overheating either material. This is why induction heating is the preferred method for separating dissimilar metals in professional settings, and why a torch, which heats everything indiscriminately, frequently causes more damage than the corrosion it was meant to defeat. The mechanic who tells you this $12 device is dangerous is swinging a propane torch 6 inches from your brake lines, your ABS wiring harness, and your CV boot, and charging you $150 an hour for the privilege of watching him do it. The tool company that warns you a circuit board cannot match their $500 unit is selling you an injection-molded plastic shell containing the identical ZVS topology, manufactured in the same region, using the same MOSFET semiconductors from the same chip fabricators, assembled on the same production equipment, and packaged inside a branded box whose printing costs exceed the value of the electronics it contains. Your grandfather did not finance a specialty tool at $22 a week on a credit plan from the back of a truck. He did not schedule a 2-hour appointment and pay shop rates to have someone else fight his bolts. He understood that a mechanical problem has a mechanical solution, and that the solution does not require someone else's permission, someone else's appointment calendar, or someone else's price tag. He improvised, he adapted, and he fixed what was in front of him with whatever knowledge and materials were available. The only difference between his generation and yours is that his generation was given the information freely, and yours has had it filtered through industries that profit from withholding it. That filter just broke. $12 and 15 minutes of assembly now separate you from a tool that professional repair facilities charge $180 per hour to apply to your vehicle. Every seized bolt on every machine you will ever work on just became a 15-second task. Every inflated repair estimate padded with corrosion labor just became negotiable. Every $500 branded tool marketed as essential just became exactly what it has always been, a $12 circuit board wearing a $488 costume. Subscribe to Forbidden Arena right now and turn on the notification bell, because the next video contains something that makes this look like pocket change, and the industries protecting it are far larger than tool companies. Hit the like button, because every single like pushes this video past the paid placements and sponsored reviews that tool manufacturers and repair chains pay to keep between you and the information that saves you money. Drop a comment below telling me the worst repair quote you have ever received for a job that turned out to be simpler than they claimed, because every comment tells the algorithm that real people solving real problems with real information matters more than another advertisement disguised as expert advice. The next arena opens soon, and what is waiting inside it makes every tool catalog ever printed look like an overpriced joke.